Question 5, retried. Apologies for the class on Friday where I was trying to show you how to do it. I had a specific way in my head. Anyway, I'm going to show you two ways of doing that question now. The first way is not going to involve the trigonometric identities. So if we have a look, basically it's referring to the first mass, which I think was of mass m. It's not that relevant anyway for the first part of the question. So it was moving at a speed of 0.6. Okay, now if we just call this, the velocity in this direction, the component of the velocity in this direction as being A, and the component of the velocity in this direction as being B. Okay, so then we know basically that the slope of that line is A over B. Now because we are told that after the collision it moves perpendicularly to the way it moved beforehand, okay, we know that the slope of this line has to be perpendicular, or at least, sorry, this line is perpendicular to this. I'm not drawing it like that because we draw it a standard way, okay? But we do know, okay, actually I'll draw perpendicularly. We do know that the new direction that it is traveling will have a slope. The slope of this line will be minus, if the slope of this line is A over B, the slope of this line will be minus B over A. Okay, so that means that effectively the minus comes from, this is the minus, so actually technically the minus is on the A bit here, but we don't worry about that. In terms of magnitude, we can't say that this is A and this is B, so that we get a slope of B over A, because it's only the ratio or the relationship between them. So when you divide one number by another, you get B over A. So if two numbers are in the ratio B over A, we can call them BX and AX, so that when you divide them, you get B over A. So effectively, what we can say is the vertical velocity for this is BX, and the horizontal is AX, and obviously in the minus. So now, what can we say here? Well, we know that this is 0.2. We're given that it's traveling at a speed of 0.2 afterwards. By Pythagoras, we can say ax squared plus bx squared is equal to 0.2 squared. Okay, that gives you a squared x squared plus b squared x squared is equal to 0.2 squared. That's x squared into a squared plus b squared is equal to 0.2 squared. Now from this, we also can see, because it's traveling at 0.6, that a squared plus b squared is equal to 0.6. So we can put that in here. So we have x squared times 0.6 squared. A squared plus b squared equals 0.6 squared. X squared times 0.6 squared is equal to 0.2 squared. X squared is equal to 0.2 squared divided by 0.6 squared. Getting the square root of both sides, x is 0.2 over 0.6. X is 1/3. Now that means x is 1/3. Okay? So we can put b times 1/3 or b over 3 here. Now that's important because the other piece of information that we haven't used yet is that, that's a over 3, is that the velocity in the vertical direction does not change. Okay, so we know that our velocity in our horizontal direction, in our vertical direction, doesn't change. So a must be equal. This has to be a. This vertical velocity has to be a. Okay, so a must be equal to b over 3. That means if a is equal to b over 3, then the tan of theta, if a is equal to b over 3, the tan of theta must be b over 3 divided by b, which is 1 over 3. Okay, because b over 3 divided by b is b over 3 multiplied by 1 over b, okay, which is 1/3. All right, so the tan of theta is 1/3, done that way. Now I'm going to do it using the trigonometric way of doing it, which is what I've been kind of trying to avoid because the fifth years hadn't covered it. Okay, so now what we have is we have basically, again, looking at our mass, we know that beforehand that it's moving at 0.6 in this direction. We can equate that, if that's theta, to 0.6 cosine theta and 0.6 sine theta. Okay. Afterwards, we have velocity in the vertical direction is preserved, so that's 0.6 sine theta. Here we have now we know that it's traveling afterwards at a velocity of 0.2, so this is 0.2 sine alpha. Okay, this is also cosine alpha. 0.2 cosine alpha, and this is 0.2 sine alpha by resolving this. But 0.2 sine alpha has to be the same as 0.6 sine theta because our velocities are conserved. Okay, now the important fact then that we use is the fact that the two lines are actually perpendicular to each other because it's traveling perpendicularly to the direction that it was traveling after the collision. So that means that alpha has to be equal to theta plus 90 degrees, okay? Because if it was traveling at theta beforehand and it's traveling perpendicularly to that afterwards, then the theta plus the 90 has to be equal to that alpha. Now we've drawn the alpha here as if it's less than 90, but it isn't. It's just the way we draw it. So if it's rotated through 90 degrees, then the angle to the horizontal that it's now going at is theta plus 90. So we know that the cosine of theta plus 90 is equal to the cosine of theta times the cosine of 90 minus the sine of theta, the sine of 90. The cosine of 90 is 0, so that gives you the cosine of theta times 0, so that's all 0, minus the sine of theta, and the sine of 90 is 1. Just very quickly, the sine of 90, that's your 360, sine, that's 180, 90. The sine of 90 is 1. Similarly with cosine, the cosine of 90, that's your 360, that's your 180. The cosine of 90 is 0, just from a graph point of view. Anyhow, that's told us that the cosine of theta plus 90 is minus the sine of theta. And the reason we're doing this is because theta plus 90 is alpha. So we now know that the cosine of alpha is minus the sine of theta. That means in here, instead of this cosine alpha, we can put in minus the sine of theta. I'm going to put the minus sign in the front. That leaves us with tan alpha is equal to the opposite divided by the adjacent, which is 0.6 sine theta divided by minus 0.2 sine theta, which is minus 3, because those two divide and 0.2 goes in 3 times. So the tan of alpha is minus 0.3. The tan of alpha is the rise divided by the run. The tan of alpha is the slope of that line. So the slope of that line is minus 3. If the slope of that line is minus 3, that means that the slope of a line perpendicular to it, which would equate to tan theta, must be equal to that number turned upside down and the sign changed. So the tan of theta is 1/3. Okay? So that's the 2 ways that I can think of doing it, and there's probably several more.